Okay, you guys ready to go? Everyone's on, what are we, day 3 here? Okay, we're on day 3. All right, so here we go. Before I start with the proofs, we need to make sure we know our properties down pat, because if I don't know a property, I'm not going to be able to use it in a proof. All right, so let's go through this. I just don't have the capacity today, guys, teaching you guys from my house to do the numbers, going back and forth. So if you guys could just open up your mics, one property of a parallelogram we went over on Friday, and let's eventually get all 5. So here we go. What do you got for me? Property of a parallelogram that we could possibly use here in a proof.
Opposite sides are parallel.
Opposite sides parallel. Keep going. I'll keep writing. Diagonals bisect each other. Go ahead. Keep going. Opposite sides parallel. Diagonals bisect. You got more in you. Let's come on. Dig deep. Opposite angles congruent. Perfect. 2 more. What do you got?
Opposite sides congruent.
Opposite sides are also not only parallel, but they're also congruent. And there is one more property with the angles.
Consecutive angles are supplementary.
There we go. Consecutive angles supplementary. All right, I will let you guys in on a little secret. Teaching this course for 18 years now, I have never done a proof, a parallelogram proof, where we have used consecutive angles supplementary. All right, so don't expect to use it. All right, so really you have to worry about those 4 right there. The sides are parallel and congruent, opposite angles are congruent, and diagonals bisect each other. All right, so don't expect to use consecutive angles or supplementary in any of these proofs. Just focus on those first 4. All right, good job. So here's what we got today. Excuse me. We got 4 proofs, and they range in difficulty from pretty darn easy to honors level pretty darn tough. All right, so expect that today in the 4 proofs that we do. Pretty easy to start it off, and then by the time we get down to proof number 4 here, we'll be sweating. All right, we'll be definitely grinding away. So let's take a look at this first proof right here. I am giving you that both figures are parallelograms. Both figures are parallelograms. And I need to know why XY is congruent to ZY. All right, XY and ZY. Why would those be congruent? First, this is not just going to be a 2-step proof. You just can't say, oh, they're opposite sides, so they're congruent. Because does everyone see that XY and ZY are in 2 different parallelograms? So you just can't say, oh, they're automatically congruent because opposite sides are congruent. They're in 2 separate parallelograms. But we can get to that point in a second. All right, I just wanted to point out that this is not going to be a 2-step proof because opposite sides are congruent. Let's first start with WX. Side WX. It may not be congruent to ZY right now, but can somebody let me know what is WX congruent to? Name another side it's congruent to.
VT.
VT. All right, take a look. XWX and VT are definitely congruent. The reason? We just applied a property. We wrote this down on Friday multiple times. Parallelogram, and you can use my abbreviation, parallelogram. I'll give you a little street cred. Parallelogram implies and then you just tell me the property we just used. You guys just used opposite sides congruent. Boom. Good work. So WX congruent to VT. Let's keep rolling. Anybody want to tell me something about ZY maybe? ZY? Because that's part of the proof statement. Anybody about ZY?
It's also congruent to VT.
Oh, look at that. ZY is also congruent to VT. Now, yes, if some of you are thinking, I could have just written that with step 2 because it's going to have the same reason, you are correct. I could have written ZY congruent to VT in step 2. I just want to, because this is our first parallelogram proof, I do want to just show you every single step written out. So if you want to stick that in step 2, fine, go right ahead. All right. Now, can we put this all together? I have Wx is congruent to Vt. Zy is congruent to Vt. Please remember, everything you write down isn't going to be about parallelograms. We have done, this is our 6th unit, and we've done proofs in every unit except for the first one. So anything we've done in unit 2, 3, 4, and 5 still can go here. And that's what's about to happen here. How do I put this together to say, oh, that must mean based on steps 2 and 3, Wx must be equal to Zy. What have we talked about in the past that says those two have to be equal now? What do you got? Wx equals Vt, Zy equals Vt. So by what postulate? Wx is congruent to Zy.
Substitution.
There you go. Good. I got a couple people going there. Perfect. Substitution. You are going to see quickly, old theorems are coming back now. Old theorem. I know we took a slight break from them with the indirect proofs, but they're coming back now. Questions on number 1, how I got to substitution. And it's not a 2-step. You just can't say automatically that those two are equal. Not bad for the first one. Pretty easy. Ready to raise your level a little bit now? Woo! Ready to raise your level? Woo! Number 2. Proving triangles. All right, we got 5 methods. Let me remind you quickly. I got side, side, side. We got side, angle, side. We got angle, side, angle. We got angle, angle, side. And then finally, we got a little HL. All right, one of those methods is going to be used at the end of this proof to prove the triangle's congruent. So I have parallelogram ABCD. What?
Could you also use their symbol that they have there for parallelogram?
I'm not going to fight it. It's not a battle I want to fight, Sophia. So if you want to do it, go ahead. That's not a battle I want to fight. Okay, I'll pick my battles, and that's not one. All right, ABC.
I directly copied the.
That's fine. Yeah, that's I'm a talking test quiz too. If you want to do that, that's fine. So ABCD. So you don't have to do this, but what I like to do, guys, is I just like to highlight what they tell me is the parallelogram, just because I know I can apply any of those properties to that highlighted figure. All right, so any of our parallelogram properties can be applied to that figure. There's also another important given. Don't overlook it, please. DF is congruent to EB. That doesn't give me a side, but hopefully it'll lead me to a side. So DF up here, congruent to, what was it, EB right here? All right. And yes, I'm just saving some time here. We can write in the straight lines. I know there is a reason they gave you straight lines, and we'll come about it in the proof here in a minute. But all right. So I need to prove those two triangles are congruent, and I gave you nothing. You have no sides and you have no angles. So we're going to have to do this together and build together here, because I did not get in the givens. I did not give you any sides or angles. So let's first start with the fact that this is a parallelogram. Can anybody find any sides or angles in those triangles that are congruent? Because ABCD is a parallelogram. Anything you see there? Can I apply a property that would give me a side or an angle?
Yeah, A is congruent to CB because systems are congruent.
Okay, ready, everyone? DA has to be congruent to CB. Opposite sides. See, if I don't know these properties, I'm just staring at this. That's it. I got to know my properties. DA congruent to CB. Parallelogram implies opposite sides congruent. All right. So I have a pair of sides down. Yes, got a pair of sides. Still need more, right? One pair of sides isn't going to cut it. Let's keep looking at the diagram now.
If you've got DF and EB congruent, could you potentially try to prove that DEBF is a parallelogram?
You need more than one pair of sides parallel. Okay, and we'll learn that tomorrow. You need both pair parallel to get it to be a parallelogram. I see where you're going there, but I would need both pair. Just not one pair wouldn't cut it. All right, others, anybody see anything else?
Could you say DC and AB are congruent and then do subtraction?
That's how one way everyone take a look. Not only are DA and CB congruent, but so are DC and AB. And I'm just going to stick that right in step 2 instead of right in another step. DC congruent to AB. Because those are opposite sides. And does everybody see what Radhika was talking about there? We're about to subtract. Doesn't go anywhere. It'll be here all year long. Subtraction. So what are we going to subtract? DF minus DC equals EB minus AB. Subtraction. And then, hey, I don't care if we're in the 6th unit or if we're in the 10th unit later on this year. Right after subtraction, you better believe substitution to tell me what two sides are equal to each other. And that would be CF congruent to EA. And that gives me a second pair of sides. All right, we are moving along. Perfect. All right, I got 2 pairs of sides. 2 pairs of sides. So I know it's either got to be side, 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 or side, angle, side, right? Because I don't have enough information for the other 3, so it's got to be one. So either you're finding me the third side or the angle in between. That's what we've narrowed it down to. What's up?
A equals C.
You
Not equals, it's congruent to C with opposite angles are congruent.
You better get more specific there, Maeve, than A and C. Because I don't know which one you're talking about.
Angle DAB and DCB.
Okay, let me show you what Maeve's talking about here. She's saying, hey, this angle right here, DAB, is congruent to angle BCD because opposite angles in a parallelogram are congruent. I'm going to write that down. I need you guys to start thinking, where's Maeve going with this? All right, because those angles aren't in the triangles, but she's going somewhere with it. So think about it as we write this down now. Angle DAB congruent to angle BCD. Again, it's a parallelogram property, so parallelogram implies opposite angles congruent. Where are we going here? Because those angles, I can't use those angles because they're not inside the triangle. But can we get them inside the triangle using an theorem from the past?
Supplements of congruent angles are congruent.
Everyone take a look. The 2 angles we just proved congruent, aren't they supplementary to angles inside the triangle? And we had a theorem in unit 2 that I showed you guys that said supplements of congruent angles are congruent. But that's not my next step. If you remember, if you want to use that theorem, you need to tell me which angles are supplementary first. So in step 6, I'm going to tell you that DAB and angle DAE are supplementary. And then right underneath, I'm going to tell you the other pair are supplementary. Angle BCD and angle BCF are supplementary.
Can you just say angle DAB supplementary angle DAE, or do you have to write that all out?
Say that again?
Could you just say like angle DAB angle DAB supplementary to angle DAE?
You can just reword. You're just rewording it. Yeah, that's fine.
Okay.
But you got to put both pairs, though. You just can't put the one pair. Got to put both pairs. How do I know they're supplementary? I haven't used this term yet. Why are they supplementary?
Linear pairs are supplementary.
Linear pairs are supplementary.
Can you also just do E is congruent to F through like opposite sides or parallelogram implies opposite sides are congruent and then for opposite angles?
But that's not the parallel. E and F isn't the parallelogram. The parallelogram's ABCD. That would be true if the parallelogram was EBFD, yes. All right, so I can't apply that property because E and F are not part of the parallelogram. So linear pairs are supplementary. Now you can say the supplements, angle DAE, congruent to angle, we got DAE and BCF. Yep. Looks like that's not congruent. Hold on. And then that's the theorem. Supplements of congruent angles are congruent. And then there is angle, the third piece of information we needed. And now I think we got the triangles congruent, right? So I got triangle DAE congruent to triangle BCF. I'm not even going to ask. I'm 100% sure we know side angle side. Okay, guys? Any questions there? Again, it's easy for me to say this, and I know it's tougher for you to do it, but the only new things I'm putting in my proof are the parallelogram properties. That's it. You're still going to see addition, subtraction, in this case, supplements of congruent angles. Wait to the fourth one, what we bring back. Real old school one in the fourth proof we do. All right, we got to get there first. Here you go, 3. Still proving triangles congruent. Make sure you guys know which one they're calling the parallelogram. Make sure you know which one the parallelogram is. This one right here, I'm highlighting in green. There's the parallelogram. Oh, got some perpendicular lines on this one. Nice. Some right angles being formed. BE and FC are perpendicular, so I got a little right angle action here. AF and FC are perpendicular. Got one right here. And again, proving the triangle's congruent. We got this. We got this. Can we just take care of the right angles now so we don't forget? All right, I don't even need to ask anybody there. Say they're right angles, say they're congruent. We know the two-step process there. So angle F and angle BEC, don't call that angle E. Angle BEC are right angles. Perpendicular lines form right angles. Got it? Then say they're congruent, and that gives us a pair of angles. Angle F congruent to angle BEC. And then there's a pair of angles. All right, so I'm turning it over to you guys now. The right angles, no big deal. We got to all see those. Is there anything I can use if that's a parallelogram now? Any other sides or angles I could get from that parallelogram?
DA is congruent to BC.
There it is. A pair of opposite sides, specifically DA and CB. So DA congruent to CB. Parallelogram implies opposite sides congruent. Side. All right, here we go. All right, this is why I think this proof is tough, or decently tough, is that third pair. Where the heck are we going to get that third pair from here? Whew. I'll let you guys take a look. Remember, it's a parallelogram, so are there any other, maybe some other properties maybe I haven't used yet that could help me? But you see anything? I don't want to just give it away and say, here it is.
Based on the fact that they have FDEC as a line, that makes me think there's something to do with supplementary angles. I just don't know how to use it.
Okay.
Is it that we can do angle DAB is alternate interior to angle FDA, and that's complementary to angle C?
Complementary?
Not complementary, sorry. I forgot the vocab term, but it's congruent.
I got you. You're just missing the vocab word, and so is everybody else, Sean. That's fine because we haven't talked about it in a couple units. Everyone ready? Remember that these lines are parallel as well. Okay? Specifically, take a look at DA and CB, everyone. Those are parallel. That's a parallelogram property. Opposite sides parallel. If you guys take a look, and I know I'm making kind of a mess here, but let me just extend these a little bit here, my parallel lines. And then let me draw in brown here, a little transversal going through them. Does anybody remember, and this is what Sean was getting at, the vocabulary term for angle FDA and angle C? On those, not consecutive. We're getting, it starts with a C. We're getting there. I got congruent, complementary, consecutive, yes, corresponding. Everyone remember corresponding. I take this 4-pack of angles, slide it down. Those two would match up with each other. So I have corresponding angles there. Yes, corresponding
I was just thinking
angles.
because I've got it written down in my properties of a parallelogram. I wrote down consecutive angles.
Yeah, but this isn't, Sophia, this isn't a parallelogram. The parallelogram property I'm using, Sophia, is that the lines are parallel. And then parallel lines make corresponding angles. Okay, I'm not saying these angles are congruent because of a parallelogram property. I'm saying the lines are parallel because of a parallelogram property. Okay, so what do I need to write here? First, you need to tell me the lines are parallel. Don't tell me the corresponding angles are equal yet because you need parallel lines. So DA is parallel to CB.
So you couldn't just try and skip this and use the property of consecutive angles are congruent?
That's not the property. They're supplementary. Consecutive angles are supplementary in a parallelogram, not congruent. Okay? So I have parallelogram implies my property, which is opposite sides parallel. And then you can tell me the corresponding angles are equal. So angle FDA congruent to angle C. And I know it's been a while, but ready? Parallel lines imply corresponding angles congruent.
Wait, I didn't even realize you were talking about corresponding angles here.
Remember
I
those?
guess those are corresponding. It's hard to tell.
It is hard. You're right. It is hard to tell. All right. That's why it makes it a little tougher. And now that should give you guys enough info because that's a pair of angles. So that should give you enough info now to say the triangles are congruent. I just need somebody to figure out, is that side in between or not? So
could we also do alternate
Yeah, I'm
substitute.
going to get to that in 1 second, Sean. Yep, there's another way to do this instead of saying corresponding. I'll get to that in 1 second. Anybody? Is that side in between or no here? What do we got? Angle, side, angle, or angle, angle, side?
Angle, side.
Got it. Angle, angle, side. There you go. 7 steps. All right, before I move on, look, I get it. Sophia just said it herself. Hey, that was tough to find that those are corresponding. There is another way to get those angles congruent if you didn't see they were corresponding. Real quick, in a parallelogram, opposite angles are congruent, correct? So you could have said angle DAB, this angle right here, DAB is congruent to angle C because they're opposite angles. With me so far? I'll write it up here. Angle C congruent to angle DAB because they're opposite. Then you could have said, oh, angle DAB is also congruent to angle FDA because they're alternate interior. I think alternate interior are a little bit easier for you guys to see than corresponding. And then with these two, you could have said, that's how you could have gotten to C and FDA being equal by substitution. All right, so there was a different way of getting those two angles congruent. All right, questions? All right, you ready to finish this off with some fireworks? Honors level coming at you right now. Last proof, honors level. Okay, make sure it looks like the whole thing is a parallelogram. Nice, this whole thing, ABCD is your parallelogram. Oh, got a little midpoint action. Oh, all right, we'll see where that leads us to. Please recognize the two triangles you're trying to prove congruent. Recognize the two triangles, the two on the outside. DEA and CFB. All right, let's start this off. Give me something, what's true. Give me angles or sides are equal because that's a parallelogram. Don't touch the midpoint yet.
Angle A is congruent to angle C because parallelogram implies opposite angles congruent.
Done, Omni, done. Angle A congruent to angle C. Parallelogram implies opposite angles congruent. Done. That gives me, there's a pair of angles. All right, anybody else want to use another property that could give me sides or angles?
DA is congruent to CB.
Yeah, that's not bad at all, right? Opposite sides, DA congruent to CB. Parallelogram implies opposite sides congruent. Okay, this isn't that bad, right? Because we've already got angles and sides. All right, now let's talk about the other givens. They're telling us that E is a midpoint and F is a midpoint. All right, let's start. If E is a midpoint of AB, all that tells me is AE equals EB. That's it. AE equals EB. And F being a midpoint tells me DF is equal to FC. But what do I need, though? We need to get AE equal to FC. And I just can't say that's true by definition of a midpoint. That's not true. AE is not equal to FC because definition of a midpoint. So what I'm going to have you guys do is go way back in the time machine. And anybody remember in our givens, if we were going to take half of two different sides, halves of two different sides, there it is, halves of equal quantities. Everyone remember that one. Halves of equal quantities are equal. That's the way we're going to get AE equal to FC. Because I see in the givens, we're taking the midpoint of two different sides. So we're going to cut two different sides in half. All right, go ahead. Questions here before we do this? Because this is a couple step process. Say the theorem out to yourself again. Halves of equal quantities. So you have to show me what you're going to take half of is equal to each other. Somebody name the two sides we're about to take half of.
DC and AB.
And take a look. What do we know about DC and AB, guys? DC and AB are congruent to each other. And you know what? Now that I look at this, we'll just put that all in step 3. All right, so I have DC. This is awful writing on this for some reason. DC congruent to AB. What you're going to take half of, you need to make sure they're equal. Okay, they're equal now. Now take half of them. Remember, we wrote these statements. Half of side DC. Half of side DC. What are we calling that side? Half of side DC. We could either call it DF or we could call it FC, but I only care about one of them. What are we going to call half of DC?
FC.
FC, the side in the triangle. And then tell me what else you're taking half of. We're also taking half of AB. And if you look at your diagram, I could call that AE or EB, but I want to call it AE instead because that's the side in the triangle. So I took half of DC, half of AB. What allowed me to take half? Because it wasn't halves of equal quantities. Halves of equal quantities is when I set them equal to each other in the next step. What gives me the right to take half of both those sides?
Definition of a midpoint.
Because it said there was a midpoint up top. Perfect. Definition of a midpoint. Definition of a midpoint. Now you could say in step 5, let's finish this, that FC is congruent to AE by halves of equal quantities are equal. And then I think you guys can finish the proof from there. This is, geez, having a tough time writing. Need my big board. Be prepared for one on the homework tonight. Halves of equal quantities on the homework. This is why we're doing number 4, so you can look back at it and not leave it blank. Not leave it blank. So we got triangle DEA, congruent to triangle BFC. This method's not bad at all. There's no question about it. Side, angle, side. All right, so watch out for that tonight on the homework. There will be a question regarding 2 midpoints again. Questions or concerns you guys have? Quiz again will be on Friday. I won't be after school today, but I should be okay for the rest of the week. All right. Questions, comments, any concerns from you guys before we wrap it up here? Okay, please do not give up on those proofs. My answer key is up on Classroom along with an updated assignment sheet for the week. Have a great day, guys. Have a great day. I feel your pain working from home now.